The first ionization energy is the energy required to remove the highest energy electron from an atom. And the general trend is, as you go across the period, left to right, it requires more energy to remove the highest energy electron. And that makes sense because as you go across the periodic table, the shielding effect remains about the same as you add electrons, but the nuclear charge increases. And the general trend for first ionization energy as you go down the periodic table is that it decreases. And that's because as you go down the periodic table, those electrons on the outside are farther and farther away and more shielded from what they're attracted to, which is the nuclear charge. So the overall general trend, is up and to the right, first ionization energy increases. That's basically what you need to know to answer the questions on your test. All right, so let's answer a few questions related to first ionization energy. Again, the trend is up and to the right, first ionization energy increases. All right, these are all taken from our OpenStax online textbook, number 69. Based on the positions, which has the largest first ionization energy? So again, the answer is going to be up and to the right. So magnesium and barium, right there, right there. So we can eliminate barium because magnesium is higher. All right, boron is even higher and more to the right. So we can eliminate magnesium. Oxygen is going to be the answer because tellurium is all the way down here. So we can eliminate all of them, and whatever is highest and to the right on the periodic table is going to be the answer. So answer number 69 is oxygen. All right, let's move on to number 70. Based on the positions, predict which one has the smallest. Now, if the question is asking which one is the least, requires the least energy to remove an electron, that's going to be the opposite trend, down and to the left. Right, like cesium and barium, those valence electrons are the farthest away relatively to the other elements on the periodic table, and they're experiencing the most shielding. Those electrons on the outside they're going to require the least amount of energy to remove. All right, so our answer is down and to the left. Lithium is all the way up here. That's not going to be our answer because cesium is cesium is going to be our answer. There's nothing more to the left. There's a few elements I cut off, but nitrogen is not one of them, and neither is fluorine, and iodine is over here. So we can cross all of these out: fluorine, nitrogen, and iodine. And the answer is going to be cesium. All right, let's move on to 71. Now this problem's asking us, based on the position, rank these elements from increasing order. So again, the trend is up and to the right, first ionization energy increases. So let's put the one that is farthest away from up and to the right. In other words, start with the ones that are farthest down and to the left. So rubidium's outermost electron, the one with the highest energy, requires the least energy to remove, followed by lithium. Lithium, nitrogen, and fluorine are all on the same period 2. So it's just from left to right is going to be how it is, and fluorine is going to require the most energy. I'll circle them up on the periodic table. Rubidium is there, lithium, nitrogen, and fluorine. All right, let me guess. The final one is going to ask us to do the reverse based on the position. Oh, no, sorry. It's the same question, just with different elements. Okay. So why don't you try this one? Which one requires the least amount of energy to remove their outermost electron? Right, the answer is going to be down and to the left, and then the most is going to be up and to the right. All right, well, oxygen is most uppest and to the rightest, so that's going to be all the way to the right. It's going to require the highest amount of energy, followed by sulfur, followed by silicon, and the magnesium is all the way to the left of the periodic table. So that's going to require the least energy to remove. All right, let's circle these up here. Magnesium, silicon, what were the, sulfur, and I forget the last one. Oxygen, sulfur and oxygen. All right, so there's our order.